This lecture draws off of chapter one in your book. We're going to get into what is quantitative analysis. Okay, so at the beginning, in quantitative analysis, the general idea is that we're going to use what many people consider to be math, right? In order to take data sets and then try to figure out some trends, some patterns, nowadays, what might be called analytics. And from that data, from just a huge data set, what we're going to do is we're going to pull out some information that makes some pretty simple, coherent sense that we can use to make quick decisions with. For example, imagine the New Jersey Turnpike or some interstate highway. When you see cars going up and down interstate highways, you see them going 80 miles an hour, 77 miles an hour, 53 miles an hour, 48 miles an hour, 96 miles an hour, 67, right? Out of all these different speeds they're going, not only do they have velocities, but they're also either accelerating, they're braking, they're changing speed, they're changing lanes, and that's just the cars around you. So, if I was to ask you to make sense of what's going on that road at that time, you might actually say to yourself, "Oh, I don't know. It's just there's all this chaos. There's so much going on that it's really hard for my brain to process." Well, at its core, what quantitative analysis does is it tries to break down all of that complex information to say, okay, well, the average speed that the car is going is 63 miles an hour, and the dispersion or the standard deviation of those speeds is 10 miles an hour. Okay. Obviously, I'm making those numbers up, right? I'm just plucking them out of the air. But what that allows you to do, if you know that the average speed of the car is 63 miles an hour with a standard deviation of 10 miles an hour, you can actually start to get some pretty good estimates, estimate being a key word here, not a prediction, not a guess, not a forecast necessarily, just an estimate. We can start to make estimates of how the general traffic is flowing on the entire road just from a little sample. Okay. And the reason why that matters is because at its core, what a quantitative analysis is doing is really something called inferential statistics or inferential analysis. Okay. And I'm going to start writing some of this stuff on the whiteboard. I'll share a whiteboard with the screen and then I will start writing on it. I just wanted to speak it out loud first, right? So, what we do with quantitative analysis or inferential analysis, what's the root word of inferential? It's inference, right? What is an inference? It's what we believe to be. So, with what we believe to be, we're going to take some information here, get some idea of what's going on within our our local set. I don't want to say population, but within our local set of data, and then use that to try to make inferences or extrapolate some sort of information out about what's going on within the larger picture, the larger world, right? For instance, if we say that there's traffic on the Verrazano Bridge at 9 a.m. today, 9 a.m. tomorrow, and 9 a.m. the next day, we can use that small, tiny set of information about traffic on the Verrazano Bridge at 9 a.m. to extrapolate or form a general idea that no matter what, at 9 a.m. and every day, there's going to be traffic on the Verrazano Bridge. So, what we're doing is we're taking samples and using that to extrapolate or infer or what we believe to be information about what's known as a population. Okay. That's the basics of quantitative analysis. Okay. A quantitative analysis is trying to make inferences. What we're doing is we're trying to figure out, okay, based upon this small set, this limited knowledge we have, is it reasonable to believe something about the general population? Okay. I'm just going to do some quick examples of that, right? So let's take Jersey City. Let's say that, hey, maybe the average income of Jersey City is $75,000. Well, based upon that average income of Jersey City being $75,000, is it reasonable to think that the average income of New Jersey is $75,000? Or based upon the average income of Jersey City being 75,000, is it reasonable to think that the Northeast or the United States could be $75,000? Okay, that's one example. Another example might be to say marketing or advertising or social media. Let's say that when you log on to your favorite social media site, they discover that you spend 15 seconds looking at each post of your best friend. Well, out of that sample of, say, 10 times you look at your best friend's post, they start to infer that every time they stick one of your best friend's posts in front of you on the phone or the tablet or whatever, you will look at that for about 15 seconds. So, in other words, every time there's 15 seconds worth of traffic, to go back to the Verrazano Bridge and that, right? Every time there's 15 seconds worth of traffic with your friends on social media, they know that this will happen every single time, right? Maybe you look at your friend's posts, just out of 10 seconds, it lasted 15 seconds. Out of 10 times, it lasted 15 seconds. Well, now they know that if they do that every single time, you will be looking at it for 15 seconds. How can that information be used? Well, if they know you're going to be looking at your best friend for 15 seconds, they should probably put two advertisements or two pop up or clickbait things right next to your friend's post because you might actually go and decide to go look at whatever that clickbait is. They're not going to stick it down by somebody that you went to middle school with or something like that, right? Because you'll go skimming right on past it. Okay. Another way that this sort of information could be used, right? Where we're talking about making inferences and large conclusions about based on limited knowledge. We're talking about making estimates, right? Another way we could do that is by saying, hey, if we have fireworks after a baseball game, it seems like that gets about 600 more people to come to the baseball game. Well, how do we know that? Well, we did it last weekend, 600 people more came. We did it this weekend, 600 more people came. You know what? I think if we put fireworks after a baseball game every single weekend for the rest of the season, that'll get us 600 more people inside the stadium, which means you have to buy the ticket, but then you also have to buy the hot dog, the soda, the popcorn, the peanuts, the hat, the ice cream, whatever, right? So that's more sales, which means more revenue and more profit for your business if you're an event space. Okay. So there's all these different things we can do with quantitative analysis, whether it's the Department of Transportation with the Verrazano Bridge, or whether it's social media like Meta or X or whatever, TikTok, right? Or if it's even the New York Mets, the New York Yankees, the Red Bull, the Rangers, the Knicks, right? Anything like that with stadiums. All of these things lend themselves to quantitative analysis. Okay, so what I'm really trying to get at here is that while this is a course designed for business, economics, and finance, quantitative analysis spans all kinds of disciplines. Okay. It's a very, very transferable skill. Okay. What we're going to do in this class is we're going to have it be applied to business, economics, and finance, which is generally where you find quantitative analysis clustered. But that doesn't mean that it has to necessarily be just for business, economics, and finance. I'll give you an easy example. Let's say that you're thinking about marketing a new cholesterol lowering drug, right? You work for a pharmaceutical company. You're not just going to launch the drug without doing something, testing it in a sample first. Instead, you're going to take 50 people, give them the drug, see if it lowers their cholesterol. And let's say on average, it lowers the cholesterol, I don't know, 20 points with a standard deviation of 5 points. Okay. Well, then what you're going to do is you're going to send the results of that experiment to the FDA and internally within the company. And you're going to say, hey, look, this new drug is safe, hopefully, and it lowers cholesterol by 20 points with a standard deviation of 5 points, right? So if this works and it lowers the cholesterol at some statistically significant level, then what you're going to do is move forward and give that to the general population, right? So we're working with samples and populations. And ultimately, this is where I wanted to go with this lesson from chapter 1, right? You can see in the lecture notes. You can see in the lecture notes the emphasis here on samples versus populations. Okay, so I'm going to share my screen and I'm going to start doing some whiteboard writing. Okay, so in quantitative analysis, the general premise, what we're working with here is we are working with samples. And we are trying to find out things about populations. Okay. I tend not to have the best writing on a board, so a whiteboard is a little challenging here, but please bear with me. I'll try to get it better as we go, right? So we're going to use samples to get information about populations. Okay. In other words, I'm going to look at 10 days worth of traffic on the Verrazano Bridge and then make an informed, estimated, generalized inference that there is always traffic on the Verrazano Bridge. I'm going to look at 10 times, if I'm a social media company, I'm going to look at 10 times you scroll past your best friend and see you look at them for 15 seconds on average. So then I will generalize and say that, hey, every time you look at your best friend, you stop for 15 seconds, right? Same thing with a stadium. Every time we have fireworks, there's 600 more people who come. So in other words, a sample is really nothing more than a part or subset of a population. Whereas a population is the whole set of objects of interest. Okay. Big thing here, the population. Usually we refer to populations as people. Could be people, but it could also be just cars on a bridge, right? It could be uh, cholesterol, right? Okay, the population is the whole set of objects of interest. It's the whole set, right? So if we want to know, um, let's just make this general. If we want to know what is the unemployment rate of the United States, right? Or how many people in the United States are currently unemployed, okay? The population would be everybody in the United States who's unemployed. That's the whole set. Okay. If the whole thing we care about is how many people in this country do not have a job, then what we're talking about for a population is the entire country, all 50 states. A sample is a part or a subset of the population. Okay. It's a part or a subset of the population, which means you just take the entire country, all 50 states, that would be our population. And then our sample could be simply one person, could be one person who's unemployed. It could be New Jersey. It could be half of New Jersey. It could be New Jersey and New York. It could be New Jersey, New York, Connecticut, and Arkansas. It could be every single state in the United States except for one state. And it could be literally everybody in the United States except for me. Because at that point, all of those potential samples that I put out there, all of those are parts or subsets of the population. And the population is really just nothing more than the whole set. Okay, the whole set. So if we want to just, really round this out, make it, excuse me, pretty easy here. If we were taking a football team, an American football team, right, the NFL, National Football League, if we were talking about a population, we would be talking about every single player on the football team. If we were talking about a sample, it could be just a handful of players on the football team. It could be the quarterback, could be the quarterback and the running back, could be the quarterback, the running back, and the linebackers. Or it could be everyone on the football team except for the quarterback. Okay. Because that would still be a part or a portion or a subset of the population. That's what we're talking about here with the relationship between samples and populations. Okay. That's what we're looking at. Okay. Now, in quantitative analysis, if we're going to make inferences, okay, to make inferential decisions. Oops. Okay. To make inferential decisions from samples. From samples, we get something that are known as statistics. Okay. Statistics. A statistic is nothing more than a characteristic of a sample. Let me see if I can erase that, make that better. Make that a bit more legible. Okay. Statistic. You've heard statistics your whole life. Oh, these statistics say this, these statistics say that. These statistics are for baseball. These statistics are for airplanes. These statistics, all these statistics. What's a statistic? Statistic is really nothing more than a characteristic of a sample. What do we mean? Let's go back all the way to our highway, right? If you remember my example for the New Jersey Turnpike or whatever your favorite interstate is, hey, what are these? Let's take all the cars that are on the New Jersey Turnpike, right? Well, if you pick 10 of them, that is a sample because you have all the cars on the turnpike, right? All the cars that are going on the turnpike would be your population because that's the whole set, right? That's the whole set. Every car on the New Jersey Turnpike would be the set. If you picked 10 of them, then you would have a sample. If you pick every car that's a Subaru out on the turnpike, that's a sample. Okay. If you look at the average speed that the Subarus are going on the New Jersey Turnpike, that would be a characteristic of a sample. Let's say that on average, the Subarus are driving 70 miles an hour. Okay. If they're driving 70 miles an hour, that is a characteristic of your sample. Your sample is all the Subarus that are on the turnpike, and that's a subset of all the cars that are on the turnpike. Okay. So then their average speed, that's a characteristic of a sample, right? That's a characteristic that becomes a statistic. Okay. 70 miles an hour, that's an average speed of your sample. So that's a characteristic of it. Okay. What we try to do, this is the whole thing, the whole point of quantitative analysis. The whole point of quantitative analysis is that we use statistics. Okay, this is the whole thing. This is a very important portion of the course to understand this. The whole thing we're going to do in quantitative analysis is we use statistics in order to estimate something that is known as a parameter. Parameter is a characteristic of a population. Okay. Parameter is a characteristic of a population. So, in other words, if you take every car on the New Jersey Turnpike, there is a true, actual, real average speed out there of every car on the New Jersey Turnpike, right? If you took every car on the turnpike right now, added them all, took them all, and calculated their average speed, that would be the true, actual, real average speed that a car on the turnpike is going. That would be the parameter. That's the characteristic of the population. However, by the time, however, it's impossible to actually calculate parameters. And this is the whole point of quantitative analysis. It's impossible to calculate a parameter because if you were going to look at every single car on the New Jersey Turnpike and figure out their average speed, you would have to start all the way down, at the bottom of New Jersey by Philadelphia, by the Delaware Bridge, right? Delaware Memorial Bridge. You would have to count up all those cars and then keep going all the way up the turnpike, exit one, exit two, exit three, exit four, exit five, right? All the way up until you got to the George Washington Bridge, right? And when you got to the George Washington Bridge, then you would have every car on the turnpike, and then you would take all those cars, add up the speeds, and divide by the number of cars, and then you would have the true actual speed of a car on the New Jersey Turnpike. Just one problem. By the time you got from whatever, exit one to all the way up at the George Washington Bridge, there would have been cars that get on the turnpike at exit 7, exit 9, exit 12. There would be cars that get off on exit 11, exit 14, right? There would be constant change. there would be more cars that get on at the Delaware Bridge, and then there would be cars getting off at the George Washington. The point that I'm trying to make here is that you can't calculate the parameter ever, because by the time you get from one end to the other, the initial starting point has already changed. And in between, you'd have cars coming on and off. So it's impossible. It's literally impossible. It's not feasible to ever calculate parameters because the parameter is the true, actual overall value of a population. And populations are always changing. That's the one constant about them, right? Is that they're always changing. Instead, what we do in quantitative analysis, because it's impossible to calculate a parameter, it's impossible to ever actually capture a full population. Instead, in quantitative analysis, in order to make inferential decisions, what we do is we calculate statistics. Okay? What we do, instead of looking at literally every single car on the George Washington, every single car on the New Jersey Turnpike between the Delaware Memorial Bridge and the George Washington Bridge, instead of looking at every single car, which we can't do, what we do is we take a sample. Maybe we look at every car between exit 9 and exit 11. Maybe we take those cars, look at what their average speed is, say that it's 70 miles an hour. And then if the average speed of each car between exit 9 and exit 11 on the turnpike, if the average speed there is 70, then what we do is maybe we say, you know what? I'm going to make the inference that the average speed of all the cars on the New Jersey Turnpike is 70 miles an hour. So, based upon my limited knowledge, my limited sample, my sample, which is a portion of the population, right? Based upon my limited knowledge or my limited sample, I'm going to make an inference or an estimate about what I believe to be. I'm making an estimate of what I believe to be. I'm making an inference about the larger population. I'm making an inference about the larger population, which is my whole set. I'm making an inference or an estimate of the parameter. Okay. Once I make an estimate of the parameter is a characteristic of the population, then I can start talking about whether it's reasonable or unreasonable to believe things. Okay. To go back to the Verrazano Bridge, hey, I took a sample of 10 days. I looked at the Verrazano Bridge today at 9 a.m., tomorrow 9 a.m., the next day 9 a.m., the next day at 9 a.m. I do 10 days. And I find out that on average at 9 a.m., the Verrazano Bridge has 25 minutes worth of traffic. Okay, well, what I do is based upon that statistic, the 25 minutes, that would be a statistic because it's a characteristic from my sample. Based upon that, I say, you know what? I think that at 9 a.m., every single day ever, every single day at the George Washington Bridge at 9 a.m., there's 25 minutes of traffic, or just about. Because that is how quantitative analysis works. What we're going to do in this class is we're going to take samples. From those samples, we calculate statistics. And then based upon those statistics, which we get from samples, those are the portions or parts or subsets of our populations, what we're going to do is we are going to estimate parameters. The parameters are characteristics of populations. That's what we're going to do in this class. And then the whole point of getting those statistics to estimate the parameters in order to make decisions about populations. Sorry, my Zoom cut out there for a second. The whole point of making those decisions in order to get our statistics from our samples, in order to make estimates about our populations, is because that will allow us to be much more efficient and effective in data collection, our time management. And as we'll see, our estimates can be very, very close and very, very reasonable to the actual the parameter values without having to take too much time spent on our data collection. Okay. Again, this is a skill that's very, very, very transferable. We're going to do it for business economics and finance, but hey, look, I just did it for cholesterol drugs at, pharmaceutical companies. Okay. Airlines do this all the time when they say, okay, on average, how long does it take to fly from Newark to Los Angeles? Well, they don't look at every single flight that has ever gone from Newark to Los Angeles. They look at 100 times flying from Newark to Los Angeles, and then they say, okay, on average, it takes 6 hours with a standard deviation of 20 minutes. Oh, okay. Well, if it took 100 flights, 6 hours to get to Los Angeles, then we can start to budget for 6 hours built into our flight times and how much gas we need. And then once we get to Los Angeles, how long do we need the plane to rest before we can turn around and use it to fly to Seattle or something like that? So what this does is, rather than looking at all the flights, the whole set of going from Newark to Los Angeles, rather than looking at everything that's ever happened, if you take a sample, it turns out that you can actually get very, very good statistical estimates of your parametric values. And that is the whole point of quantitative analysis. That's what we're going to do in this class. That's chapter 1. In the next lesson, we're going to start to look at measures of location, measures of dispersion, mean, median, mode, standard deviation, variance, range, things like that. And we're going to start getting into how we actually operationalize things, like averages, right, standard deviation, how we operationalize those through something known as the empirical rule. The empirical rule will help us make very, very good managerial decisions, right? Logistical, operational decisions. And I cannot stress to you enough how much it is used in your everyday life. If you just look around you right now, you look around at your computer, at your phone, at your shoes, right? At your desk, at everything. What's really behind it getting to you, and in terms of supply chains use the empirical rule all the time. Okay. It really is the basis for many things we do in business, economics, and finance. And so that's where we're going to pick it up. I'm going to end this video now because we're done with chapter 1, and then we'll pick it up again with chapter 3.